We're going to wrap up our introduction to Nyquist by talking about control constructs, including conditionals and loops. So let's start with conditionals. This should be pretty familiar from other languages. The if-then-else statement allows you to evaluate a condition and execute one statement or another. And so examples here are if pitch is greater than C4, then return flute of pitch, and otherwise return tuba of pitch. Here's another one. If velocity is greater than 127, then set velocity to 127. So in SAL, the then keyword and else keywords are followed by single commands. So if you need to do multiple commands, use the begin-end construct to contain multiple commands. And this is a classic programming language design problem called the dangling else problem. If you have something like if condition 1, then if condition 2, then S1 else S2, where does this else belong? Is it the else part of the second if, the innermost if, or the first if, the outermost if? To be honest, I don't even know, and I wrote this code. You should never write a statement like this. Instead, use begin-end brackets to disambiguate and remove the dangling else. And then even the reader will know what your code does. So that's if then else. The other control construct is the loop command. And the basic syntax of a loop is just the keyword loop, followed by a sequence of commands, followed by end. Kind of like begin, end. And in fact, you can add a with after the loop to declare local variables in the loop. Now, the thing that makes loops complicated is there are a bunch of options. You can loop with a variable taking on integer values. For example, you can write for I from 0 below 10. So that means I will take on the value 0 through 9. You can iterate over a list of elements. We haven't even talked about lists, but we'll get there. So you can say for element in some list. You can do a more flexible iteration by saying for some variable equals an initialization expression, and then every other time through the loop, run an update expression to compute the new value for the variable. You can also say while expression to give an arbitrary stop condition, or until expression, which is another, just reverses the true false condition for stopping. You can repeat a loop n times by writing repeat n. And at the end of the loop, when the loop decides to exit, you can add a clause called finally and give a statement, or actually a compound statement, of things to do when the loop exits, while the loop variables still have values that you can access. So there are a lot of options here, and my advice is keep it simple and always consult the reference manual, which has a section that lists all of these different loop options, because even I forget some of the details, and you just need to be able to be aware of what they are and be able to look them up. So let's look at an example of a loop. This is a function definition, and here, when we learned about function definitions, we gave the full syntax, which was define, function, function name. As you can see here, we left off the keyword define, which is allowed. We just simplified it to writing function, so you can do that. This is a function called pluck chord. So it's going to construct a chord of plucked string sounds, and the parameters are the starting pitch, the interval between pitches, and the number of pitches to put into the chord. So these are only going to be chords with equal intervals, no major, no minor, but you could make a diminished chord or a cluster of whole steps or something like that. Okay, so the body of the function is a begin-end construct, and what we do is we define a local variable s by setting it to the value of pluck pitch. So that is going to be the fundamental, the root of the chord, and then we're going to stack notes on top of that note using a loop. So we're going to loop, we've already done the first pitch, so we're going to loop starting at 1 below n. So this loop will actually iterate n minus 1 times. And each time through the loop, we're going to set s, the sound, to the sum of itself using the plus equal assignment. We're just adding in a new plucked sound, which is going to be the root pitch plus interval times I. That's how many times we've been, I is how many times we've been through the loop, and interval is the number of steps between each pitch. And then we return S. And we've called the chord a couple of different ways. Here is starting on C3 with the interval of 5 semitones, which is a perfect fourth. We do another one with D3, interval of a perfect fifth, and here's a very interesting chord with a lot of notes. The interval is a minor seventh between each chord tone. And I've loaded that code up into Nyquist, so we can just do a file load and listen to it. So now you know about if statements and loops. You can define functions, you can write expressions, and you are ready to program in Nyquist.